Today we are going to learn about optimizing word embeddings for NLP tasks. This video will guide you through the process of fine-tuning word embeddings for specific NLP tasks, enhancing the performance of language models in real-world applications. By the end, you'll know how to adapt embeddings to improve the accuracy of your NLP solutions.
Welcome to our video on optimizing word embeddings for NLP tasks. Word embeddings are a type of word representation that allows words to be converted into numerical vectors, enabling computers to understand human language. These embeddings are crucial in NLP as they capture semantic relationships between words. Historically, they evolved from simple frequency-based models to more sophisticated ones like Word2Vec, GloVe, and fast text. Understanding these embeddings' role is key to leveraging their full potential in modern NLP applications. Optimizing word embeddings for specific tasks is essential to enhance the performance of NLP models. Each task, whether it's sentiment analysis, translation, or question answering, has its own unique challenges and nuances. By fine-tuning embeddings, we can capture these nuances more effectively, leading to improved accuracy and performance. For example, embeddings optimized for sentiment analysis can better distinguish positive and negative sentiments, while those fine-tuned for translation can better capture linguistic subtleties. This task-specific optimization is what makes NLP solutions more robust and applicable to real-world scenarios. Fine-tuning word embeddings involves several methods that tailor them for specific tasks. Pre-training methods, like leveraging large datasets to learn general patterns, serve as a foundation. Transfer learning allows us to adapt these pre-trained embeddings to new tasks by focusing on relevant features. Domain adaptation further specializes embeddings for specific sectors, such as medical or legal texts. Layer-wise fine-tuning adjusts different layers of a model separately, ensuring that the most relevant layers are optimized. Regularization techniques, such as dropout, prevent overfitting by adding noise during training, ensuring the model generalizes well to unseen data. Let's explore a case study on enhancing sentiment analysis using optimized word embeddings. Sentiment analysis involves classifying text based on emotional tone, such as positive, negative, or neutral. Initially, a baseline model using generic embeddings might struggle with context-specific sentiments. By fine-tuning embeddings on a sentiment-specific dataset, we observe significant performance improvements. The model became more adept at capturing subtle emotional cues, leading to higher accuracy. This case study highlights the power of task-specific optimization in NLP, demonstrating that tailored solutions can greatly enhance model effectiveness and reliability in real-world applications. Integrating optimized embeddings into existing NLP models requires careful consideration of compatibility and architecture. Embedding layers serve as the initial processing stage for transforming input text into vector representations. During training, embeddings can be fine-tuned to align with specific task requirements. Adjustments to model architecture, such as adding custom layers or modifying existing ones, can further enhance compatibility and performance. Practical integration tips include ensuring that embeddings are of appropriate dimensionality and considering computational resources. This integration process ensures that the full potential of optimized embeddings is harnessed in your NLP solutions. Evaluating the performance improvements of NLP models with optimized embeddings involves both quantitative and qualitative measures. Key performance metrics include accuracy, precision, recall, and F1 score. By comparing these metrics with those of a baseline model, we can assess the impact of embedding optimization. Quantitative evaluation provides a numerical perspective, while qualitative analysis involves reviewing model outputs for correctness and relevance. Iterative improvement, where feedback from evaluations is used to refine embeddings further, ensures continuous enhancement of model performance. This comprehensive evaluation process is vital for validating the effectiveness of embedding optimization. While optimizing word embeddings can greatly enhance NLP models, there are common pitfalls to be mindful of. Overfitting occurs when embeddings are too closely tailored to the training data, leading to poor generalization on unseen data. Misalignment with the task can result from improperly fine-tuned embeddings, reducing model effectiveness. The computational cost of optimizing embeddings, especially for large datasets, can be substantial. Data bias, where embeddings reflect bias patterns present in the training data, can also affect fairness and accuracy. Strategies to mitigate these pitfalls include using regularization techniques, ensuring a diverse dataset, and employing bias correction methods. The future of embedding optimization in NLP is marked by exciting trends and innovations. Contextual embeddings, which consider the context in which words appear, are becoming increasingly popular. Hybrid models that combine different types of embeddings for enhanced performance are also on the rise. Cross-lingual embeddings facilitate tasks involving multiple languages, broadening the applicability of NLP solutions. AI-driven optimization, where machine learning algorithms autonomously refine embeddings, is another promising trend. These advancements are set to revolutionize NLP, enabling more accurate, efficient, and versatile language models that can tackle a wider range of tasks and challenges. In conclusion, optimizing word embeddings for NLP tasks is a powerful technique that enhances model performance and applicability. We've explored the importance of task-specific optimization, methods for fine-tuning, and practical integration into existing models. By understanding and applying these concepts, you can significantly improve the accuracy and reliability of your NLP solutions. As the field continues to evolve, staying informed about future trends will ensure your readiness for new challenges. I encourage you to explore further, applying these insights in your own projects to unlock the full potential of NLP.